Welcome everybody to Module 1, Lesson 2. We're going to be covering System of Linear Equations. To help you prepare for this lesson, you need to go back to Module 1, Lesson 1 and review graphing lines in slope-intercept form, especially if you missed that lesson. We will need those skills for today's lesson. For today's learning objectives, we're going to be able to solve systems of linear equations by graphing. We will also solve systems of linear equations in 2 or 3 variables by substitution or elimination. By the end of this lesson, you should be able to identify inconsistent systems of equations containing 2 variables and also solve applied problems using systems of linear equations. Here is our QR code, but I'm guessing you don't need that since you are already here. But as a reminder, you can pause and rewind this video as often as you need. This lesson is literally at your pace, so use those tools as needed. And here we go. Let's go ahead and actually just jump in. Pause this as you need to get this all copied down. But here are the 3 things that can happen when I have a system of linear equations. The first thing that can happen is I'm going to have 2 lines. So that's why it's called system of linear equations. We will have 2 different lines. Next lesson, I believe we're going to go on even to 3 lines, but 2 lines, and they're going to intersect somewhere. And where that intersection is where my one solution is. And so that one solution will always be as an ordered pair since we're talking about the plane. And so this will be x, comma, y. So we'll need an x and we'll need a y. Now, these 2 here are kind of our special cases. They don't happen as often. Most of the time, we're going to get one solution with 2 intersecting lines. But these things can happen as well. So we can have 2 lines that are parallel, which means that slope is the same. So my slope isn't quite the same. This one's tilted just a little bit more. So try to make those as parallel as you can. But if I have 2 lines that are parallel, which means the slope is the same, right? The rise and the run are the same. And so if the rise and the run are the same, they're never going to intersect. So if they never touch, that means I have no solution. Another thing that can happen is I will graph one line and then the same line is also going to be graphed right on top of it. It's just going to be wrote in 2 different forms. And so when this happens, we have infinitely many solutions. And so you can see because we have one line on top of another line, we have all of these ordered pairs, right? And that's not all of the ordered pairs that we have because these go on infinitely in more directions. So you're going to have more ordered pairs as those lines expand. And not only that, but I have solutions in between all of these ordered pairs too. So infinitely many since you have literally one line on top of the same line. So here is visually what our system of equations looks like. One solution is one intersecting, or the lines intersecting at this one point. No solutions means they're never going to touch because we have 2 parallel lines. And then infinitely many solutions when I have one line on top of each other. And so we have infinitely many. Now, in this lesson, we're going to review the following 3 ways to solve system of linear equations. We're first going to start by visually graphing these. Then we're going to use these 2 algebraic methods, substitution and elimination. So next video, we will start with graphing.